introduction. If you are in any way linked to the data engineering community here in Perth, you know him. He is the founder of, I'm going to get my notes out because I do not want to get it wrong. All right, so we've got Data Engineering Camp, founder of that. You're also a big organizer of Data Eng Bytes and of the Data Engineering Meetup. Thank you very, very much for all of that. And I think all of us data engineering enthusiasts have seen Jonathan speak before, have at least been to a meetup that's benefited from his involvement and contribution. But by day, Jonathan is a data engineer at Canva, where he is scaling data platforms to handle petabytes of data and hundreds of internal users. So today, Jonathan's going to tell us a bit more about Canva's journey with data engineering platforms. So no further ado, ladies and gentlemen, Jonathan Neo.
Awesome. Hi, everyone. My name is John, and today I'll be chatting to you about Canva's journey from a monolithic data platform to a decentralized data platform. Just a quick show of hands here. How many of you are familiar with the concept of a data mesh? So about 20%. And how many of you, of course, are familiar with the concept of microservices? I expect everyone is. So data mesh effectively is what microservices is to data. So that's what we call it. Oops, it's not working. Oh, all right, there was a lag. So a little bit about myself. There was a quick introduction there. So I've worked at a couple of different consulting places in the past, Redify, Telstra Purple, the Mentor Group, and primarily through data engineering roles, contracting to different clients. And most recently, I've joined Canva about a year ago, and also founded a data engineering bootcamp called Data Engineer Camp. So come speak to me afterwards if you're interested more about the bootcamp stuff. We're going to be covering a lot of ground today. We're going to start from the beginnings of the data platform at Canva. We're going to talk about what challenges we faced in that point in time, and then we discuss solutions and a couple of things that we would have preferred to have done differently if we had the time again. So going way back, this is sometime in about 2017. Things were a lot simpler when we started the data platform. We had a couple of data engineers, about 3 or 4 of them actually, and we had a couple of use cases that belonged to different domains in the business. So think of a domain as a product team, finance, HR, different use cases within the business that needed to analyze data for some kind of business improvement or product improvement. So the data engineers themselves would support those use cases by gathering requirements, creating the ETL to extract data, bring it in, transform that data, and then produce some kind of dashboard or data outcome for the end users. Our data stack at the time was pretty straightforward. It looks a bit complex here, but I promise it's simple. We basically went to a vendor, and the vendor said to us, yes, we can give you an entire data platform on a subscription basis. We'll provide you with compute, storage, all that's going to be covered, just pay us a fixed fee. So that vendor essentially provided to us what's known as a customer data platform. So everything's kind of provided out of the box through a subscription model. And then they also included several different open source technologies that supported us in different requirements. So one of them was like data ingestion from first-party sources. So we used MySQL database for our backends for our applications at Canva. And there was an open source tool called Embulk that we used to ingest data from MySQL. We also had a bunch of third-party APIs that we needed to integrate with to get data from. And that's where actually we spent a lot of time trying to build custom scripts to connect to things like Salesforce, Facebook ads, Google ads, yeah, and a bunch of different APIs that we had data in that we wanted to gather insights from. So there was like a lot of time spent writing Python scripts and testing that, and it took about 4 weeks and for each connector, and you have to maintain the connector as well when API updates. So it was a lot of effort for that. But once data gets into our CDP, we have different layers that we process data. So we have what's known as the raw layer, which meant that we try to keep the data as close as we can to what source is emitting. So if the source is returning us JSON, we want to store JSON as rows in our tables. If there are data types and columns that we can use, then we effectively replicate that schema across into our warehouse. We have a staging layer where we perform some kind of cleansing on our data. So we do things like deduplication, maybe renaming columns to make things a little bit more easier to work with. And lastly, we have the MAD layer, which is where we perform data modeling so that we can meet the requirements or the use cases downstream of us. So a bunch of different use cases like BI use cases, using things like Mode and Looker, machine learning use cases, running on Kubernetes and SageMaker, and then experiments as well, or A/B testing that we were doing. To support all that, to perform the crunching and the computation, the CDP was using 2 different SQL flavors, Hive and Presto, and they were using another tool called DigDag to orchestrate or to create the dependencies between the transformation steps. So that was our data platform in the very early days, and I have to say it was really easy to get started. Like I said, it's just a subscription model, and the vendor took care of everything for us, including the cloud hosting. All right, but as we know, Canva doesn't just stay fixed. We grew quite quickly. So in fact, if I press this here, nope, all right, keyboard. So we grew at a rate of, I want to say like 15 million plus users every year. And currently we're at 100 million monthly active users using the platform or Canva application. So with that huge amount of growth meant that we had a lot of demand as well for different analytics use cases. There were a lot of different product features that we're including, and each product team wanted to get insights and better decisions on how they can improve that feature. So demand skyrocketed. How much did it skyrocket by? We have about 5,000 plus code merges into the data warehouse repository every year. Bearing in mind a code merge means like could be 10, 20, 30 commits in one PR. And so we have 5,000 of those. And to put things into perspective as well, we have currently around 250 data contributors to the platform, so which consists of people like data analysts, data engineers like myself, machine learning engineers, backend engineers also contribute code sometimes. So a lot of different contributors to the platform. What this meant for our initial central data engineering team is that we had a lot of fires to put out. So as the years gone by, more and more use cases emerged, and we took that on. But over time, we were kind of effectively spread too thin to address the needs of all the business requirements. So people were screaming at us saying, something's broken, please fix it. I need this data refreshed by this time for this very important use case or reporting requirement, and we were just everywhere. There were a couple of issues as well with the stack that we found was challenging. And as I mentioned before, the key one for us was like custom ingestion. We spent about 4 weeks per API to ingest that data. And not only that, but we had to maintain that connector as well. The other issue is that the Hive and Presto created some confusion because there are 2 different SQL flavors that were not compatible with each other. And also pricing started becoming expensive because we started reaching petabyte levels of data ingestion and data processing. And so the subscription model worked at the beginning, but it became very expensive when we needed to get more compute power. And DigDag is kind of a bit of a weird one. Like nobody uses that, so it's really hard to integrate that in our stack. So we had to pivot. No, okay. And we had to pivot to a different team topology or new ways of working, and also a different technology stack to support this new use, the current demands. And so here are the 5 key design decisions that we made to help us to shift towards that new world. I'll talk through each one, and we'll dive into specifics. The first is architecture decoupling. So we took a big step back and said, all right, so what is our data platform actually doing today? It's taking data from something, it's crunching it, and it's spitting it out. But if we were to think about the components that make up this data platform, what are those components? And so we landed on, or decided there were actually 3 components that we needed to think about. The first is data ingestion, so getting data in. So we had to connect to some data source and land data into our destination. We had a data compute and storage layer, and also we had a data transformation layer, which means the layer that takes care of the logic for the code that we wanted to run. So those were the 3 layers. Then we explored tooling that would meet our requirements both from a functional and non-functional perspective. So functional meaning that if it's data ingestion, then functional means we need to pull data from the sources that we have. So we have a list of sources that we have, like MySQL, DynamoDB, and all the different APIs that I mentioned before. And then it needs to land data somewhere, specifically some kind of warehouse that we'll choose later. And then non-functional requirements like scale is a big one. We're talking about petabytes of data from our source systems. So those are kind of requirements that we needed to meet. And so we looked at tools that would address those requirements for each of the components or layers of the stack. And what we landed on, wants to go to the next slide. Nope. All right. So what we landed on was we used a bunch of tools for first-party ingestion. So primarily tools that were provided from AWS. I'll dive into specifics on that one later. We use Fivetran for our third-party data ingestion. So because Fivetran has a lot of different connectors to third-party data sources, like every API, every popular API, I should say, Fivetran will have a connector for. And we also went with Snowflake. So I know there's a booth outside for Snowflake. So Snowflake was great because it provided us with separate compute and storage. And it was just really easy to get going with it. And dbt as well, which I'll, again, talk more later on. So that was the stack that we went with. The next thing we looked at was decentralized ownership. So here's what the ownership model looked like in the beginning. We have the data engineering team in the middle. And they would be responsible for all data assets across Canva. So like I mentioned, the raw, the staging, the marts. We would then work together with different domain teams, gathering their requirements, and then build those data models as per those requirements. What we shifted to is effectively microservices, as I said, or a data mesh. So what we did was that we took assets that were pertaining to a domain team and gave those assets to those domain teams and made it their responsibility to now look after those assets and continue to build on top of them or create new models. But we also wanted to ensure that the quality of those assets were pretty high. We didn't want the quality to drop after we handed them those assets. So where it was possible and where there was budget to it, of course, as well, we embedded an analytics engineer within those teams. So we said, you're a very big team. You have very high value use cases for Canva. So you're gonna basically hire an analytics engineer, or you can get one from us, but you take over the responsibilities of their pay, and embed an AE within each of those teams. So an AE is just another word for a data engineer, but we decided to create a different term for the data engineer because their role is a bit more focused now on just the data modeling aspects and not so much on data infrastructure. So that was the big shift. Some teams didn't have an AE. Some teams just operated purely off their existing data analysts. And so that's where, I guess, quality can kind of change a little bit. Another important thing to mention here is that we still, as a warehouse platform central team, took control of certain assets that were important to the business, particularly assets that were cross domains. For example, a user, the definition of a user is consistent across whatever domain you belong to. So we wanted to still maintain and build those assets from the central perspective. Another aspect of decentralized ownership that helped us enable us to get there was a notion or concept called namespaces that we coined ourselves. I don't think it's a new concept. Maybe our naming convention of that concept is a bit newer, but if you use, say, Databricks, for example, you'll be familiar with concepts like workspaces. So effectively, we're just creating a space for developers to do work. And so that was important for us because we wanted to have consistency across what teams were doing. As you can imagine, if each domain goes off and chooses its own stack, and one team's using Redshift, one's using Databricks, one's using Snowflake, we get a bit of a nightmare to try to manage and reconcile. So we came up with a concept called namespace, and that defined what users can do, where data can come from, how data gets into a namespace, and what's in a namespace. So what can they do in a namespace? So there's storage, which is our Snowflake storage sitting on S3. There's compute, which is Snowflake Warehouse. There's access, which is the RBAC model through Snowflake as well. There's tooling that we provide through dbt, and then orchestration through cron jobs running on Kubernetes. So that was what they could do in that space, and then data can also leave a namespace. So data can come into a namespace and leave a namespace, And data can be exchanged from namespaces as well. So a namespace can consume data from one other namespace and can go out to another namespace. So that was one thing that helped enable consistency across the domains. The next key design decision we took was simple extractions. So we wanted to make sure that our developers are as productive as possible. So if you look at the original data platform syntax here that developers had to write at the time, it was quite complicated. There are two files that the developer had to write. A file for the SQL code on the left side of the screen, and another file on the right side for the pipeline steps to say, run this step, then the next step, and so on. So there were pipelines that were pretty large. There were like 20 to 30 steps, and it became very messy to try to understand, okay, I need this to run first before this, and what if this has a dependency on this 5 other things? And effectively, you have to try to write all that and work through that logic. So productivity was a bit down. Instead, we moved towards dbt, which made the whole dependency structure a lot simpler through using macros or Jinja macros if you used that before. So you can see here in the from statement in that SQL query, we simply use Jinja quotes and place a Jinja function in there called ref. And that tells dbt that saying that, oh, this query or this table 2 that I'm building depends on table 1. And it creates the dependencies just like that. So a lot simpler, more declarative for the end users. The next one is self-service. So because we are wanting to empower others, we didn't want to kind of make ourselves the bottlenecks to parts of the stack. So as much as possible, we created tooling and automation for developers in the domain teams to self-serve different elements of the platform. So 3 of them that I want to discuss with you is data ingestion, command line interfaces, and development environments. So first is data ingestion. So developers need to ingest data into the platform or the namespace. How do they do that? First-party data, we use Terraform modules to configure a bunch of AWS resources in the background. So effectively, you go in, put in some parameters, run the apply statement, and then out spits DMS to extract data from MySQL database or DynamoDB that pushes that or writes that into Kinesis data streams. Data streams then drops it into S3. Once it lands in S3, we have Snowpipe that collects that and ingests that into Snowflake. So that was the pipeline for first-party data. The third-party one was pretty simple as well. So we use Fivetran, as I said, lots of connectors Fivetran provides. And today, because it's so easy, we have 250 Fivetran pipelines that are running in production. Another important aspect of self-service is the command line interface. So there were a lot of tasks that the developers found themselves doing over and over again, and some of it was pretty cumbersome. So one of them was with the usage of dbt, they needed to set environment variables to effectively connect to the Snowflake instance and provide credentials. So always before you do dbt run or any commands, you need to connect to Snowflake. And so to automate that process, we created a wrapper CLI that we effectively go and fetch secrets from Secrets Manager and then set the environment variables before then running dbt. Another one was rebuild chunks. So oftentimes developers maybe change the state of their backend. There's some historical reasons why things need to change, but we need to re-ingest or re-backfill the data again. So that's another process that we've created CLI for to automate. And this one is pretty interesting. This is probably the one that I think is the most exciting one for me. It's development environments. So when we started with the platform, we had a single shared development environment for all users. As you can imagine, that very quickly ran into race conditions where developer 1 would overwrite some developer 2 changes, and they would step on each other's toes effectively. And so what we wanted was a separate environment for each feature that the developer was building. How do we do that? So what is a feature? A feature effectively is going to be contained within a Git branch. So we said, all right, so as soon as the developer creates a Git branch, they have the option to run a command. And that command will then create a zero-copy clone of the production database. And that spins up a new database just for them with the production data, a copy of it, in a separate database environment. So that's what we did. So we used a feature from Snowflake called zero-copy clone. Effectively, you're just creating pointers to data in S3 without actually moving data across. So it was a very low-cost operation that could run very quickly. Now with the new environment, developers can now do dbt runs against the new environment. Lastly, trust but verify. So that did not render very nicely. There we are. So we wanted to empower and let people use the platform and get them to build things, but we also wanted to make sure that they're doing things to a high degree of quality. So we had continuous integration pipelines, as you expect, to verify every code change that's being merged. So in our pipeline, we did things like linting of the DBT SQL code and also some Python scripts that we wrote, unit testing of those Python scripts, and then lastly, a DBT Slim CI. So if you're not familiar with that, that's totally okay. There's some blog articles that explains this concept of Slim CI. Effectively, it's just saying if a developer creates a new column or consumes a column, ensures that the referential integrity is there between those columns. All right, so those were the 5 key design principles that we had implemented. So architecture decoupling, decentralized, ownership, simple abstraction, self-serve, and trust but verify. So it sounds like everything went well, right? But that's not the case, as one would know. There were a couple of things that we would have loved to have improved if we could get a chance to again. So, so key lessons learned. Just one really that I want to go through right now is tribal versus institutional knowledge. So we scaled the platform, we scaled people across the platform, or we scaled resources across the platform, but we did not scale the knowledge transfer, unfortunately. And so what this looked like was that the very first few engineers that we hired had a very strong understanding of what the platform is and how do you use the platform, how do you model data in the platform, what are best practices. The next round of engineers, like 2 years, 3 years ago, would have pretty strong understanding as well because they had been mentored and trained up by those founding engineers. But the most recent rounds of hires we had around 6 months to a year ago, myself included, we were kind of considered late engineers, and that's where the knowledge gap is really evident. So what happens because of that poor knowledge, is that we're finding that there's poor data modeling practices, and because there's poor modeling practices, we're not reusing existing assets. We're in fact creating a lot of new models because we don't understand how to do good modeling. And what happened today is that we have 8,000 DBT models in production. So 8,000 different tables even in production, as you can imagine. That's massive and very, very expensive. So as a result of that, we have higher KTLO, or keep the lights on burdens, meaning we have lots of bugs, lots of errors, and we often have to spend a lot of time troubleshooting some random error that crops up somewhere. So what we're trying to get to is what we call institutional knowledge, where, as you expect, documentation and training, right? But the idea behind that is that we want to ensure that any new engineer that we're hiring will come in and have a very strong understanding, or as strong as the founding engineer's understanding of what they should be doing in the platform. Specifically, I guess some examples of things we're trying to do here. Here we are. So we're using GitLab as a bit of an inspiration as to the kind of docs we're trying to get to. So GitLab has open sourced their data platform handbook. So if you want to check it out, there's a link there. I'll share the slides as well. But it's awesome. It's lots of things we kind of trying to emulate with what they're doing. Another resource as well is Airbnb's Data University. So Airbnb has created a program that essentially trains up anybody in the business on what data is. So they start from level 100, which is data awareness. So every user in the business, or anybody in the business, should really have that understanding of what data can be used for and how it can empower product teams. Up to level 300, which is you're a data engineer, you're going to be building different data assets. So that's, again, something we're trying to emulate as well. All right, with that, I think that's my time. So thank you for your time and patience. I'll open up now for questions.
A few round of applause, please, Jonathan.